Standard file I/O is really very easy to do using the standard I/O library. Here I have a working copy of fileio.cpp from chapter 9 of the exercise files. You'll notice the first thing here on line 2 that I'm using the C standard I/O header. I've been using that in our working.cpp files throughout most of this course because that header provides printf, but it also provides most of the file I/O functions as well. Down here on line 13, fopen is used to open a file. Fopen takes two arguments, a C string for the file name and a C string for mode flags, and we'll get to those in a moment. And it returns a file handle, which is a pointer to a structure, which is defined by this file macro in all capital letters, which is defined in the C standard I/O header. And that file handle is used to access the file. You notice this fputs call here, which uses that fw, file for writing, file handle, and the string that is going to be printed, or rather put in the file. And you see our string is defined here as a character string. The distinction between fputs and puts is that puts always writes to the console to standard out, and puts also puts a line ending and flushes the buffer when you're done. In this case, we're not flushing the buffer because we're just going to close the file, and fputs does not include that new line, and so we're including it in our string. Now let's take a moment to talk about this string here, which is the mode string. A mode string will be a combination of these letters, which are called mode flags. R is used for opening a file for read, and if the file already exists based on the file name, it will read the file from the start. And if the file doesn't exist, it'll return an error. If the mode string is a W, it will create a file for writing, and if the file already exists, it'll destroy the contents of that file. If the file doesn't exist, of course, it'll create a new file. The append mode will write from the end of the file if the file already exists, and if not, it'll create a new file. And then we have these same three modes with a plus sign, and so R plus opens the file in read-write mode, and it will read from the start, and if the file doesn't exist, it will fail. W plus also opens for read-write. It will create a new file if the file doesn't exist and destroy the contents if the file does exist. And A plus opens the file for read-write, and when you write from it, it'll write from the end. So it sets the file pointer at the end of the file, and it'll create a new file if the file doesn't exist. Then there's this final mode string flag, which is the letter B, and that'll be combined with any of these other ones. And this is for binary mode. And this is because text files are handled differently in different operating systems. So without the B, the system will assume it's a text file, and your operating system may or may not decide to translate file endings. One major operating system that does translate file endings is Microsoft Windows. So you need to be aware of this if your code is targeted to Microsoft Windows or any other operating system that does this, and you can test it to find out whether it does, but we know that Microsoft Windows does this. Without the B, it'll translate your line endings for you. So if you have new lines in your code and you're writing those new lines to a text file without the B mode, then it'll translate those to carriage return line feed combinations. And that's just on Microsoft Windows. Unix-like operating systems like Linux or Mac OS X will not. Generally, the B string is ignored in operating systems where it's not needed, so it doesn't hurt anything to include it. So if you're writing a binary file where you don't want those translations to happen, then you need to include the B flag. For our purposes, we're going to be writing a text file, so you notice I do not have the B flag here. I just use this for loop to write lines of text to the file using fputs, and then I close with fclose, and there's our file handle again, and printf done. And then I open the file for reading, and you notice here my fopen has an R, so it's opening the file for reading. I'm using fgets, which is the opposite of fputs, to get strings, and the string goes in this buffer. The max string constant is defined here at the top as 1024. And fgets has three parameters: the pointer to the buffer, and the maximum amount to read for a line of text, the maximum size of your buffer, and the file handle. And then I use fputs, which is like puts, which we've been using before, with a couple of differences. Puts without the F at the front will put a string to the console using standard out. and it will also add a line ending at the end and flush the buffer. fputs does not add a line ending and does not flush the buffer, and it does not assume any particular output file stream. You can specify standard out here, or I could specify, as I did up above, another file handle, which is the file that I had open for write. And so fputs is more flexible, and it doesn't do a couple of things for you. And so in this case, since it's not including a new line at the end, I have a new line in my string that I'm writing to the file. So I'm reading it from the file and I'm writing it to the console using fputs and specifying standard out as the file, which is the console file stream. So now when I build and run, you notice it writes to the file and then it reads the file and it prints those strings back out to the console. So that's reading from the file that it prints those strings out. And you notice also that I close the file after writing to it and I remove the file. This actually deletes the file from the file system, this remove call, and we'll cover that in a later movie. So for writing text files, this works great. I'd like to also show you briefly about writing non-text files. And so we're going to delete this working copy, and I'm going to grab file.io struct.cpp and copy that into our project. And I'm going to run clean. And when I build and run this, you'll see that what we're doing here is we're writing and then reading this structured file that has a couple of binary numbers and it has this literal C string in it. And so we have this structure here, which has space for a couple of 8-bit numbers, 8-bit unsigned integers, and space for a character string up to 125 characters. And it has +1 for the null byte at the end of the string. And this is a literal C string and the name of our file. And so first I'm going to write the file. So I open it for write, and you notice I have the B here because I'm actually writing a binary file. If one of these numbers is the same value as a new line, I don't want it translated. And so I'm writing a binary file, so I'm using the B there for our binary mode. I create a buffer using that structure, and I use a for loop to write the data. So the first number is going to be this incremented integer from the for loop. That's why we have 0, 1, 2, 3, 4 there. The second number is going to be the length of the string, which is 27 bytes. And then we're going to have the string in the buffer. And then I make sure that the buffer is terminated and I write the buffer. So fwrite, the first argument is the buffer address. The second argument is the number of bytes to write. The third argument is the number of records to write. In this case, it's just 1. And the fourth argument is the file handle, which I've opened with fopen here. And that's all in the for loop. I close the file and then I'm going to open it again for reading. So here I'm opening it with RB. And so the B again is binary mode, and I'm opening it in read mode. I have another buffer to read it into. And now I'm using fread to read the file. Fread returns the number of bytes read. So when that gets to 0, I'm going to assume I'm at the end of the file. And so the while is just checking that return code, the number of bytes read, and when it gets to 0, the while loop will end. And so I read it directly into the buffer. The first argument is the buffer, the second is the size, the third is the number of records, and the fourth is the file handle. And once I've read it into the buffer, then I can just dereference my buffer as I normally would and print out the number and the length and the string, and we get this result down here at the end. Then I close the file, I delete the file, and I'm done. So this is all very simple and straightforward. This is the basics of how you do file I/O using the C++ standard library.